Welcome! Every developer's journey begins with this exact program. It's a rite of passage. Today, we are going to instruct the computer to output text directly to your screen using a built-in tool in Python. Let's look at the code, line by line. Notice that symbol at the very beginning? That's called a hashtag or a pound sign. In Python, this tells the computer, hey, ignore this line. We call this a comment. Comments are written in plain human language, not code. They are just notes left by the programmer for themselves or for other developers to explain what the program is doing. The computer completely skips over this line when running the program. Next up, we have a blank line. Python doesn't mind blank lines at all, they are just used to give the code some breathing room so it's easier for human eyes to read. Now, let's move to the star of the show, line 3. Print, hello, Edulexis. Let's break this down into 3 tiny pieces. Inside. Print, the parentheses, and the text inside. First, we have the word print. In Python, this is a built-in function. Think of a function like a machine that has a specific job. The print function's entire job in life is to take whatever you give it and display it out loud on your computer screen. Second, notice the parentheses right after the word print. These act like a basket. Whatever you want the print machine to display, you have to throw inside this basket. Finally, look inside the basket. We have the words hello, Edulexis, wrapped tightly in quotation marks. In the coding world, text wrapped in quotes is called a string. We use quotes to tell Python, treat this exactly as plain text, don't try to look for hidden code meanings here. Just print these exact letters and characters. So, when we put it all together, Python skips the comment on line 1, sees the print command on line 3, grabs the text inside the parentheses, and proudly flashes hello, Edulexis onto your screen. And just like that, you've written and understood your very first Python program. Congratulations, and welcome to the world of coding. Hey everyone! Welcome! Today, we're going to look at how Python handles basic math and stores information using something called variables. Think of Python like a super smart calculator. Let's break down this simple 4-line program step by step. Here is the first line of our code. See this line starting with a hashtag symbol? In Python, this is called a comment. The computer completely ignores this line when it runs the code. It's strictly for us humans to write notes to ourselves or other programmers explaining what the code does. Here, it's telling us we are about to assign numbers to descriptive variables. On line 2, we create a variable named num1 and set it equal to 5. Think of a variable like a labeled cardboard box. We write the label num1 on the outside of the box, and we drop the number 5 inside it. On line 3, we do the exact same thing, we create a second box, label it num2, and drop the number 10 inside it. Now, Python remembers these 2 numbers for us. Here, we create a third box and label it sum_result. To figure out what goes inside it, Python looks at the right side of the equal sign. It goes back to our previous boxes, grabs the 5 from num1, grabs the 10 from num2, and adds them together. 5 plus 10 is 15, so Python takes that final answer, 15, and stores it safely inside our new sum_result box. Finally, we want to actually see our answer on the screen. That brings us to the last line. The print function is Python's way of talking to us. It shouts whatever is inside its parentheses out onto the screen. Inside the parentheses, we gave it 2 things separated by a comma. First, we have the text of the sum is inside quotation marks. Because it has quotes, Python prints those exact words word for word. Second, after the comma, we put our variable sum_result. Notice there are no quotation marks here. That tells Python, don't print the word sum_result, go look inside the sum underscore result box and print the actual value hidden inside. When you run this program, Python automatically puts a space between them, and your screen will display the sum is 15. And just like that, you've written a program that stores data, does math, and displays the result. Great job! Hey there! Welcome! Today, we're going to look at a small but incredibly powerful Python program that makes your code interactive. Instead of just talking at the user, this script actually listens to them, takes their input, and responds dynamically. Let's break it down line by line so you can see exactly how the magic happens. First up, we see a line starting with a hashtag or pound symbol. In Python, this is called a comment. Think of comments as sticky notes left by the programmer for the programmer. The computer completely ignores this line when running the code. It's just there to remind us that our next goal is to ask the user for their name using the console. Now, let's look at line 2. There is a lot of cool stuff happening here, so let's unpack it from right to left. On the right side, we have input, enter your name. The input function is like a question box. It pauses your program, prints the text enter your name on the screen, and waits patiently for the user to type something and hit enter. For example, if you type in the name Srikanth and press enter, Python grabs that text. But where does it put it? That brings us to the left side, name equals. The single equal sign in programming is called the assignment operator. It takes whatever the user typed and stores it inside a temporary storage box called a variable. We named our storage box name. So now, whenever we use the word name later in our code, Python will remember it stands for Srikanth's. Next, we hit another comment. This one simply tells us that our final step is to dynamically greet the person who just typed their name. Finally, we have line 4. This is where we show the result to the world using the print function, which displays text on the screen. Inside the parentheses, we are doing something called string concatenation, which is just a fancy programming word for gluing text together. We use the plus signs like glue. We take the fixed text hello, glue it to our name variable, which Python instantly swaps out for Srikanth, and then glue it to the final piece of text. Welcome to Python. When you run the whole thing, the console will beautifully print out, hello, Srikanth. Welcome to Python. And just like that, you've written a dynamic, interactive Python program. Keep coding, and I'll see you in the next one. Hey everyone. Welcome. Today, we are going to look at a classic beginner program, an even or odd number checker. This is a fantastic way to learn how your computer makes decisions using something called if-else statements. Let's break it down line by line. Let's look at our very first line. There is a lot happening here, so let's read it from the inside out. First, we see input, enter a number. The input function is like a prompt. It stops the program, flashes a cursor on the screen, and waits for the user to type something in and hit enter. But here's the catch, anything a user types into a computer starts off as text, what programmers call a string. Even if they type the number 7, Python sees it as the text character 7, not a mathematical number. We can't do math on text. To fix this, we wrap that entire input inside int. The int stands for integer, which is just a fancy word for a whole number. This instantly converts the user's text into an actual math-ready number. Finally, we store that number inside a storage box, a variable named number. Now, the computer will remember whatever value the user typed in. Now we get to the core logic of the program. This is how the computer decides what to do. Next, we start with the word if. Right after it, we have our condition. That percentage sign. Number %2 equals 0. Percent isn't calculating a percentage here. In Python, it's called the modulo operator. Think of it as a division, but we only care about the remainder. So, number. %2 tells the computer, divide our number by 2, and give me whatever is left over. As we know from basic math, any even number divided by 2 has a remainder of exactly 0. Next, notice the double equals sign. Equals equals. In programming, a single equal sign sets a value. But a double equal sign asks a question, is the left side exactly equal to the right side? So, this whole line literally translates to, if our number is divided by 2 and the remainder is exactly equal to 0. Oh, and don't forget that colon symbol at the very end of the line. It acts like a gateway, telling Python, if this condition is true, run the code that comes right below me. If the math we just did turns out to be true, meaning the remainder is 0, the computer moves to line 3. Notice how this line is pushed inward? That's called indentation. It tells Python that this line belongs to the if statement above it. It will only run if the number is even. Here, we use print, which simply displays text onto the screen. In this case, it happily announces, this is an even number. But what if the remainder wasn't 0? What if the user entered an odd number like 7? Well, the computer skips line 3 entirely and jumps down to line 4. Else. Think of else as your catch-all backup plan. It translates to, otherwise, if the condition above wasn't true, do this instead. Just like the if statement, it ends with a colon, waiting to trigger its own block of code. And finally, line 5. Just like before, it's indented to show it belongs to the else section. If the number failed the even check, the computer runs this line and prints out, this is an ODD number. And that's it. Because of how if else works, the computer will only ever print one of these two messages, never both. You've just built a smart little program that can analyze data and make a decision. Keep practicing, and I'll see you in the next one. Now we're going to build a super useful utility tool, a Celsius to Fahrenheit converter. This program is fantastic for beginners because it shows you exactly how Python handles user data and performs real-world math using standard scientific formulas. Let's break it down line by line. Let's look at this first line. There is actually a lot happening here, working from the inside out. First, we see the input function. Think of input as a window that pops up asking the user for information. Inside the quotes, we wrote enter temperature in Celsius. This is called a prompt. It's just a friendly text message telling the user what they need to type. Now, by default, anything a user types into a computer is treated as text or a string. But we can't do math on text. You can't multiply the word 20 by 5. So, we wrap that entire input inside the float function. A float in Python is just a fancy word for a decimal number like 23.5 or 98.6. This converts the user's text into a real number we can use for math. Finally, we take that decimal number and store it inside a container called Celsius. This is a variable, and you can think of it like a labeled cardboard box. Whatever temperature the user types in is now safely stored inside the box labeled Celsius. Next up, line 2. This is where the magic happens, the math. 140. We create a brand new variable, another labeled box, called Fahrenheit. Inside this box, we are going to store the math result. Look at the right side of the equal sign, Celsius * 9/5 plus 32. Python looks inside our original Celsius box, grabs the number the user gave us, and multiplies it by 9. The asterisk symbol is how we say a multiply in coding. Then, the // symbol divides that result by 5. Just like in standard school math, Python follows the order of operations, so it does the math inside the parentheses first. Once it gets that number, it adds 32 to it. The final calculated Number is then saved inside our Fahrenheit box. Finally, line 3. Our math is done, but the computer is currently keeping the answer to itself. We need to show it to the user. We use the print function, which is Python's way of shouting something out onto the computer screen. Inside the parentheses, we give it two things, separated by a comma. First, we give it a piece of text in quotation marks. The temperature in Fahrenheit is. This prints out exactly as you see it. Second, we put a comma, and then we type our variable name. Fahrenheit. Notice that Fahrenheit does not have quotation marks around it. This tells Python, don't print the literal word Fahrenheit. Go look inside the Fahrenheit box, grab the calculated decimal number, and print that instead. The comma automatically adds a nice, clean space between our text and our number. And that's it. In just 3 simple lines of code, you've learned how to ask a user for a decimal number, perform a scientific calculation on it, and print the result beautifully back to the screen. Try running it yourself, type in 0 for Celsius, and watch it perfectly output 32.0 degrees Fahrenheit. Happy coding, and I'll see you in the next one.
Thank you for watching. Like if you learned something, share with your circle, and subscribe for more.